There is a particular moment that arrives late at night, when the world grows quiet enough to be honest. You are standing alone at a window, the room behind you dark, the glass cool beneath your fingertips. Outside, the city stretches into the distance, a scattering of lights stitched across the land. Near lights glow warm and distinct. Farther away, the lights thin, soften, and slowly dissolve into darkness. One by one, the furthest lights vanish, not because they have gone out, but because distance has finally won. It is an ordinary moment, a human moment, and yet it contains an assumption so deeply embedded that it often goes unnoticed. The assumption is this: that life, if it exists elsewhere, is a matter of finding the right planet, the right distance from the right star, the right temperature, liquid water, a familiar checklist repeated so often that it feels complete. When we imagine aliens, we imagine worlds. We imagine oceans beneath alien suns, forests under unfamiliar skies, perhaps cities glowing faintly against a planetary night. We imagine standing on a surface, but standing at the window, watching city lights fade with distance, another thought quietly emerges. No single building creates a city. No single street defines it. The city exists because of scale, structure, history, and balance. Because violence is rare enough, resources are steady enough, and time has been generous enough. What if life in the universe works the same way? What if planets are only windows, and the real question lies far beyond them? For decades, the search for life beyond Earth has followed a clear and sensible path. Astronomers locate stars. Astronomers find planets. Astronomers ask whether those planets might hold water, warmth, and chemistry friendly to biology. This approach is not wrong. It is careful. It is grounded. It has revealed thousands of worlds, many of them surprising, some of them strangely familiar. And yet, something about this method has begun to feel incomplete. A planet does not exist in isolation. A star does not shine alone. Every world is embedded in a larger environment, an environment shaped not by kilometers, but by thousands of light years, by explosions that happened millions of years before the planet formed, by radiation that arrives long after life begins. Even Earth, often treated as a self-contained miracle, is anything but isolated. The atoms in human blood were forged in ancient stellar deaths. The stability of Earth's orbit depends on the quiet cooperation of the solar system. The long history of life on Earth was shaped by impacts that did not destroy it, and by radiation that did not overwhelm it. The problem, slowly coming into focus, is this: a planet can be habitable and still never host life that lasts. The deeper question is no longer where life can begin. The deeper question is where life can survive long enough to matter. As scientists widened their view, something unexpected happened. The neat boundaries of habitability began to blur. Stars differ in temperament. Some burn calmly for tens of billions of years. Others flare violently, stripping atmospheres from nearby planets. Galaxies differ even more dramatically. Some are chaotic, filled with frequent stellar explosions. Others are quiet, aging slowly, forming stars at a measured pace. Life, it turns out, is sensitive not only to warmth and chemistry, but to violence and time. Heavy elements, carbon, oxygen, iron, are not evenly distributed across the galaxy. These elements, essential for planets and biology, are produced by generations of stars. Too early in a galaxy's history, and there are not enough of them. Too late, and the environment may become hostile in other ways. Supernovae, the violent deaths of massive stars, are both creators and destroyers. They seed galaxies with the elements of life. They also flood surrounding space with radiation capable of sterilizing entire planetary systems. Here, physics begins to strain against intuition. A galaxy must be active enough to create the building blocks of life, but calm enough not to erase life once it appears. A galaxy must form stars steadily, but not too rapidly. Radiation must exist, but not dominate. Time must pass, but not without interruption. This balance is not guaranteed, it is fragile, it is rare, and it forces scientists to ask a larger, more unsettling question. Is habitability not a planetary trait, but a galactic one? From this tension emerged a quiet but profound idea, the concept of a galactic habitable zone. Just as planets may occupy a narrow band around a star where conditions allow liquid water, galaxies may contain regions where long-term biological complexity is possible. Not everywhere, not always, but in specific neighborhoods shaped by distance, history, and chance. Near the center of a galaxy, stars crowd tightly together. Supernovae are more frequent, radiation levels rise, gravitational disturbances become common. Life here, if it begins at all, may struggle to persist. Far from the center, the opposite problem emerges. Fewer stars mean fewer heavy elements. Planets may be rare. Chemistry may never reach the richness needed for biology. Between these extremes lies a broad, uncertain region, neither too violent nor too barren. A region where stars form slowly, where radiation events are spaced out by millions of years, where planets have time to cool, stabilize, and evolve. Our own solar system appears to reside within this middle ground. But even this idea is incomplete. Time matters as much as location. A galaxy evolves. Star formation rises and falls. Radiation environments shift. What is habitable now may not have been habitable billions of years ago, and may not remain habitable billions of years into the future. Life, especially complex life, requires not just the right place, but the right era. And intelligence, technology, communication, the ability to reshape environments may require something even rarer, long stretches of uninterrupted stability. This realization reframes the search for alien civilizations. Perhaps the universe is not empty. Perhaps it is simply patient. If life depends on galactic scale conditions, then intelligence may be less a product of biology and more a product of history. Civilizations would not arise wherever chemistry allows, but only where time, safety, and complexity overlap. Only where extinctions are spaced far enough apart. Only where radiation storms do not reset evolution again and again. This possibility reshapes the meaning of silence. The absence of detected signals may not indicate rarity of life, but rarity of endurance. Intelligence may flicker into existence often, but fade before it learns to announce itself. Technology may rise briefly, then vanish, erased by forces too vast to negotiate with. Even the search for technosignatures, artificial signals, structures, or energy use takes on a new tone. Detection would not merely reveal intelligence. Detection would reveal survival across cosmic timescales. It would mean that somewhere in a galaxy not unlike our own, life passed through countless filters. It avoided annihilation. It endured radiation. It navigated its own self-destruction. It lasted long enough to be noticed. If that is the case, then intelligence is not the inevitable outcome of life. It is the rare outcome of stability. And suddenly, standing at the window, the city lights take on a different meaning. Cities persist not because buildings exist, but because collapse is avoided long enough for memory to accumulate. Because generation follows generation without complete erasure. Perhaps galaxies too must be kind in this way. Eventually, the night grows deeper. The city lights that remain visible are only the closest ones now. The distant lights have faded completely, not abruptly, but gently, as distance and darkness claim them. You are still standing at the window. The original question returns, quieter than before, but heavier. If aliens exist, is this galaxy their best chance? Not because it is special in isolation, not because it is the largest or the brightest or the most dramatic, but because it may be stable enough, old enough, calm enough, balanced between creation and destruction. The answer does not arrive cleanly. Science, at its edge, rarely offers certainty. It offers narrowing possibilities. It offers humility. It offers awe. Somewhere, perhaps, life emerged under a different sky, in a different spiral arm, beneath stars that burned just gently enough. Perhaps intelligence arose and wondered, as humans do, whether it was alone. Or perhaps the universe is filled with beginnings that never reached endurance. Standing at the window, the glass cool, the darkness deep, one truth remains clear. The search for others is no longer just a search for planets. It is a search for places where time itself has been merciful. And whether such places are rare or quietly common remains one of the most profound unanswered questions the universe has ever posed.